Good morning, friends. In the last lecture we have studied about scalar product and vector product, that is also called as dot product and cross product. These two products we have studied in the previous lecture. In the today's lecture we are going to discuss about the scalar triple product and its geometrical interpretation. Now, how two vectors are multiplied with each other scalarly or vectorly, we have studied in the last video. Now, when the three vectors are there, what are the three types of vector what we have to consider here? That is A bar, B bar and C bar, three vectors, A bar, B bar and C bar. And we know that B bar cross C bar is a vector. B bar cross C bar is a vector. When these two vectors are multiplied scalarly, then it is called as scalar triple product. And if two vectors are multiplied vectorly, then it is called as a cross product, cross triple product or vector triple product. That is A bar dot B bar cross C bar. This is called as a scalar triple product. A bar cross B bar is a vector. If these two vectors are multiplied by third vector, that is by a dot, then it is called as a scalar triple product. Triple product are two types. One is called as scalar triple product and another is called as vector triple product. That is A bar cross B bar cross C bar, that is called as vector triple product. Means triple product are two types. One is called as scalar triple product and another is called as vector triple product. In the today's lecture we have to discuss about the scalar triple product and what are its geometrical interpretation we have to consider from this derivation. Now, scalar triple product, first of all we have to discuss, that is first one, scalar triple product. In short, we have to say that STP, scalar triple product. Now, scalar triple product, we have to consider A bar dot B bar cross C bar. Here, B bar cross C bar is a vector and A dot B bar cross C bar will be ultimately a scalar. This is two vector. A bar cross C bar is a vector, and when it can be multiplied a dot product, dot, that is A bar, means it is a scalar. Dot product of two vector is a scalar quantity and cross product of two vector is a scalar vector quantity. So it may be dot of two product or it may be A bar dot B bar cross C bar. This is what we have to say that scalar triple product. Means B bar cross C bar is a vector and A bar dot B bar cross C bar is a scalar ultimately, and the component of A bar, B bar and C bar is given by component of three vector A bar, B bar and C bar are given by, that is A bar चे component, how the vector can be expressed, that is A bar is equals to X into I cap plus AY into J cap plus AZ into K cap. This is the representation of vector, and here AX, AY, AZ are the component of A. X, comma, AY, comma, AZ. This is the component of A. Then B bar is equals to bx comma by comma bz. This is the component of b, and c bar is equals to cx comma cy comma cz. These are the component of say c. First vector a bar, these are the component. Second vector b bar, these are the component. Third vector c bar, these are the component. From this component, what we have to say that is we have to take the scalar triple product. Now what is scalar triple product? That is a bar dot b bar cross c bar. This can be expressed as, how the first vector can be written? That is a bar is equals to ax into I cap plus ay into j cap plus az into k cap. This is the first vector. And then we have what? A dot product of 2, that is dot product. And then what we have to say that b bar cross c bar, and b bar cross c bar, this is the two vector. And how the two vectors can be expressed, we have studied in the last lecture. That is vector product of a two vector, or what we have to say that a cross product of two vector can be expressed in the form of determinant, and this determinant can be written as how? That is I cap, j cap and k cap, and this can be written as, what is the product? What we have? B and C, or we have B and C. What are the component of B? That is component of B is Bx, By, Bz. What are the component of C? That is Cx, comma Cy and Cz. These are the components. What we have to say that this is a determinant, and this can be solved. How we have, see here, that is equals to dot product of two vector, that is ax into I cap plus ay into j cap plus az into k cap, and then dot product, and this can be written as, that is first vector, what we have to say that is I cap into bracket, the product of these two, and then this one, what we have to get that by cz minus, this can be written as what? Bz cy. This is the first component of what we have I. Second sign is what we have to say that minus j cap into bracket, this can be here removed, and product of this minus product of this, that is bx cz minus bz cx, and third term is again what we have to say that plus, that is k cap into bracket, this can be here what we have dot product of bx cy minus by cx. This is the expansion of the determinant we have. Now we have to use the unit vector property. What is I dot I? It should be 1. J dot j, it should be 1. And k dot k also, what we have to say that 1. We have to express the property, and then secondly what we have to say that I dot j, it should be 0. J dot k, it should be 0. First of all, we have to multiply this with component of I. What we have to get? That is, first of all, we have to say that x, I dot I is 1, and it gets what? Ax into by cz minus what we have to say that this is the component of I, and so it can be multiplied for this also, that is ax bz cy. This is the first term for what we have to say that I component. Secondly, we have for j component, that is here sign is what? Plus, and here sign is what? Minus. So I dot j, j dot j, it should be 1, and this can be considered as what we have to say that here we have to take the plus sign, because here minus plus, so the first term is this one and this gets what? Minus. So what we have to write that is we have to write that j dot j is 1, then ay multiply this is minus plus term is what we have, that is plus term is, this can be written as what we have to say that ay bz, and what we have to say that cx, right? This is the first term. Secondly, minus term is there, minus ay bx cz. This is the multiplication of second, and the last one is what we have to say that multiply by z. What we have to get that, this is what we have to write that az plus az bx cy, and plus this is what k dot k is 1, and this can be minus sign is there, az by cx. Now we have to get that how many terms? 6 terms, but we have to necessary is what we have. Here we have to consider that is first of all we have to consider this common is what we have, vector is what? Ax, means we have to write that ax into bracket what we have? by cz minus bz cy, and then there is ay into bracket bz cx minus bx into cz plus az into bracket bx cy minus by cx. This is, and after that we have to say that this can be written as, that is equal to, we have to write that ax ay az with bx by bz cx cy cz. See here, ax into bracket by cz minus bz cy. Secondly, ay into bracket what you have to say that bx cz sorry, minus here we have the second term is taken as positive, so bz into cx minus bx into cz, and third one is az into bracket bx into cy, this is bx into cy minus cx into by, and this is what we have to say that a bar dot b bar plus c bar, means we have, that is scalar product of the scalar triple product of the vector can be written in terms of what you have to say that determinant, and that can be considered as, that is by changing rows of determinant it can be easily shows that changing rows of determinant what do you have to get at a bar dot b bar cross c bar is equals to b bar dot c bar cross a bar is equals to C bar dot A bar cross B bar. This is what we have to say that by changing rows of determinant. That is, it can be so that A dot B cross C is equals to B dot C cross A is equals to C dot A cross B, and this can be written as scalar triple product and dot scalar triple product or dot product or cross product are interchangeable. So it is interchangeable. So scalar triple product, it is interchangeable. This can be considered as A bar cross B bar, A bar, B bar, C bar is equals to B bar, C bar, A bar is equals to C bar, A bar and B bar. It is also called as box product. Multiple choice question may be asked on that. Scalar triple product is also called as box product. Q1, scalar triple product or dot product or cross product are interchangeable. Remember, scalar triple product are interchangeable. It is also called as a box product. And then, what are the geometrical interpretation for a scalar triple product? For geometrical interpretation, first of all, we have to remember this is the component of A bar, B bar, and C bar. We know the scalar triple product A bar dot B bar cross C bar. Vector A can be expressed as AX into I cap plus AY into J cap plus AZ into K cap, and T cross C means dot cross product of two vector can be expressed in the form of determinant. Solve this determinant, so it can be becomes scalar triple product can be expressed or written in the form of determinant, that is Ax, Ay, Z, Bx, By, Bz, Cx, Cy, Cz. So scalar triple product is also called as a box product. Box product. It is also called as a box product, and its rows can be interchanged. So scalar triple product and vector triple product can be interchangeable. This is, we have to write down all these things are very important. And after that, what are the geometrical interpretation for the scalar triple product? Now we have to write the geometrical interpretation. मल्टिपल चॉईसच्या हिशोबाने अभ्यास करत असताना हे लक्षात ठेवा, स्केलर ट्रिपल प्रोडक्ट and vector triple product can be interchangeable. Then scalar triple product is a scalar quantity, vector triple product is a vector quantity. Now geometrical interpretation, we have to write that A bar dot B bar cross C bar means scalar triple product of three vector is equals to volume of geometrical interpretation. First point is important here, that is scalar triple product of three vector is equals to volume of parallelepiped. Scalar triple product of three vector is equal to volume of is equals to volume of parallelepiped. One more property we have studied in the 11th standard, that is scalar vector triple product, vector product of two vector. This can be expressed in the form of what determinant, and after that it can be a vector product of two vector is equals to product of magnitude of to vector, that is what we have to say that it is expressed as area of parallelogram, that is equals to area of parallelogram means what, base into height, that is equals to magnitude of product of two vectors. And this is what we have to say that for triple product, very important property, scalar triple product can be expressed, product of three vector is equals to, that is volume of parallelepiped. Multiple choice question may be asked on that. Scalar triple product is equals to volume of parallelepiped. The scalar product and vector product are interchangeable. Secondly, then properties for determinant, what we have to say as scalar product, sometimes also called as a box product. It is also called as a box product. Scalar triple product is also called as a box product. It is also one more important property. From properties of determinant, we write that is box product is what, A bar, B bar, C bar, A bar, B bar, C bar, that is equals to minus BAC. BAC minus of BAC, that can be also written as minus of CAB that can be also written as minus of ACB. This is one more property. Box product can be interchangeable, so it can be written in this way. For the cyclic permutation, three vectors A bar, B bar, C bar does not change the value. For cyclic permutation, STP does not change value. Scalar triple product does not change the value. For cyclic permutation of the few vectors does not change the value of scalar triple product, while anticyclic permutation change a sign and leaving the magnitude unchanged. For anticyclic, what we have to say that change the sign, and this can be also what we have to say that for unit vectors we have to say that I cap, J cap, K cap is equals to Kij is equals to Jki, and this can be equals to 1. If the order is changed, the sign should be negative. For anticyclic, that is Ikj, that is equals to Ikj, that is equals to -1, like that. This is the properties we have to say consider here. Vector lies in the plane and volume of parallelepiped is a 0. Volume of parallelepiped is 0. When vector lies in the plane, volume of parallelepiped is 0. These are some geometrical interpretation discussion. We have to say that scalar triple product of two vector is equals to volume of parallelepiped. Scalar of triple product of three vector is also called as a box product, and properties of determinant can be expressed in this way. For cyclic permutation, scalar triple product cannot be changed. For anti-cyclic permutation, it should be negative, and then for unit vectors, box product should be in the cyclic order 1, and anti-cyclic it should be -1. When vectors are lies in the plane, volume of parallelepiped is 0. When vectors are lies in the plane, volume of parallelepiped should be 0. This is called as a scalar triple product. Remember, these are the very important. That is scalar triple product and its geometrical interpretation. Scalar triple product is also called as what? Box product. Multiple choice question will be asked on this. Scalar triple product is also called as box product. Vector triple product and scalar triple product can be interchangeable, and then also the scalar triple product of three vectors is equals to volume of parallelepiped. Multiple choice question may be asked on that. Then if the three vectors are lies in the plane, then its volume of parallelepiped should be 0. These are the very important multiple choice question asking on this article. So exam is going on the multiple choice. So we have to focus on such type of points are important. Okay, thank you.